All right, so our goal for the evening is to learn two things. Thing one is how to multiply polynomials, and then thing two is how to divide them. And we're going to do both of those this evening because multiplying and dividing are closely related. Now, multiplying polynomials is pretty simple. The hardest multiplying polynomials ever gets is it's the distributive property. We're going to start off with a pretty basic one. Multiplying two monomials together, 6x multiplied by 4x. So when you're multiplying these together, we want to use a property that is called the commutative property. And the commutative property says that when you are multiplying, you can shuffle up the order of the things you're multiplying however you want. For example, 5 times 3 is equal to 3 times 5. The order doesn't matter. You get the same answer no matter what order you multiply in. So we're going to use the commutative property to rewrite this problem so that we group the numbers together and then group the x's together. When you multiply polynomials, the numbers go together and the x's go together. Okay.
So it doesn't work if you have 3 numbers, right?
It would work if you had 3 numbers. If you had 6x times 4x times 2x, we would still put all the numbers together. Okay, so 6 times 4 is pretty easy. 24. What's x times x?
2x.
X plus x is 2x. X times x is x squared. And that is the answer to this multiplication problem, 24x squared. So you multiply the numbers, then you multiply the variables, and that's the end. Okay. Same thing here. We're going to group up the numbers. So the numbers are -7 and 2/10 or 0.2. Times the variables, which are x squared times x to the 5th. Who knows, without a calculator, what 7 times 2/10 is?
7 2.
That's 7 plus 2/10. What's 7 times 2/10? Nobody? Harsh. 1.4, you're close. And it was a negative times a positive, so negative 1.4. And then flashback to when we learned about exponents. Who remembers the rule? X squared times x to the 5th.
I would say add the 2 together.
Uh-huh.
X7.
You are correct. Add the exponents, x to the 7th. Well done, sir. Well done. I can tell your math teacher is excellent. Okay, that was decimals. Let's do one with fractions. Oh, let's do negative fractions.
Sure.
I think by gross you mean what the face of God must look like. And I agree. So let's see if you can do this without doing the regrouping step. Let's see if you can skip this regrouping step right here. First, you multiply the numbers. So negative 1/3 times negative 2/9 is?
8.
You're adding. Negative 1 times negative 2 is 2. 3 times 9 is?
18.
Why do you hurt me? 27. Negative times negative positive. 2 27ths won't reduce, so we're good there. Now let's look at the variables. X to the 5th, and x is?
X to the 6th.
X to the 6th. Beautiful. Yeah, fractions aren't bad. So all 3 of these problems that we just did are a monomial multiplied by a monomial. You multiply the numbers together, then you multiply the variables together, the end. What if they aren't monomials though? For example, let's do a monomial, 5x, multiplied by a binomial, 2x cubed plus 6.
Isn't that where we have to,
This is distributive property, exactly right. And we know it's distributive property because we have a set of parentheses with two terms inside of it with one thing outside the parentheses. So here's what we're going to do. And I'm going to write this out the long way first. Eventually you won't have to write this step because you'll get good at these. But for now I'm going to write it out the long way. First we do 5x multiplied by 2x cubed. So I'm going to write that out as 5x multiplied by 2x cubed. And then 5x multiplied by 6. 5x multiplied by 6. And what sign goes in between the two? Plus. All right, so let's put our stuff together. Multiply the numbers.
okay. 10,
10. Multiply the variables.
x4,
X to the fourth, good. Then multiply the numbers. 30. There are no variables to multiply together, it's just an x, so we'll leave that as multiplied by x, and in between, a plus sign. Why would it be incorrect for me to now write 40x to the fifth? Why would that be wrong?
it's an addition problem.
Uh-huh. Uh-huh. So can I add those two?
Sure.
Okay. Can I add those two? No. Why not? The exponents are different. Different degrees can't be added. That's it. I'm done.
Here's the one.
The end. Can't add them if the degrees are different. Okay, let's do another one of these. Let's do a monomial multiplied by a trinomial, negative 3x to the second power, plus 5x squared plus 6x minus 1. Okay, one piece at a time. We'll do negative 3x squared times 5x squared. Then we'll do negative 3x squared times 6x. Then we'll do negative 3x squared times negative 1. Okay, just like before, let's multiply the numbers.
Okay, so 15. Negative 15.
Negative 15. Nope, let me get my equal signs here. Then multiply the variables.
X squared or x4.
X to the fourth, good. Moving on to the next one. Multiply the numbers.
Negative 18.
Good, so I'll do that as a minus 18. And the variables.
X squared.
X to the third, good.
30. Oh, I did write down 2.
And then finally, a negative 3 times a negative 1 is a positive 3, so we're going to do plus 3 because it's positive. Yeah, just x squared. Good. Can I combine any of those? No.
No,
They all have different degrees, different exponents, so the end. And that's a monomial multiplied by a binomial. So far, so good? Yes? No? Maybe? All right. What if we had a binomial multiplied by a binomial? Let's do 3x plus 2 multiplied by 2x minus 5. Okay, so you may remember from back in your Algebra 1 days of high school that multiplying these two together uses a technique that some math teachers, some terrible, terrible math teachers who owe the world an apology, refer to as the FOIL method. Have you heard of the FOIL method?
Is that factoring?
No, it's multiplication. If you have not heard of the FOIL method, you have lived a blessed life. Do not learn the FOIL method ever.
Probably did.
If you have learned the FOIL method and you've forgotten it, you are one of the chosen ones. Let it remain forgotten. And if you learned FOIL and it still haunts your nightmares, we're going to put you through some therapy to forget what FOIL is. What FOIL means is first, outer, inner, last. It is the order in which you would multiply a binomial times a binomial. I hate the FOIL method. I hate it. Now, if you need to cook something over a campfire, FOIL is the way to go. If you need to protect your brain from alien rays, FOIL is your last line of defense. But when it comes to multiplying polynomials, for the love of all that is pure and holy, do not use FOIL, and here's why. FOIL only works if it is a binomial multiplied by a binomial. That is a small, small, tiny fraction of the polynomials we will multiply. Binomial times binomial. I do not know why algebra teachers get obsessed with FOIL. It is one of the many, many, many problems that we algebra teachers experience is adherence to dumb little mnemonics. Do not think FOIL ever. Instead, when you see polynomials multiplied together like this, I want you to think the same thing you thought when we did a monomial multiplication a minute ago, which is that this is distributive property. FOIL only works sometimes. Distributive property works every time. It's distributive property. If you see FOIL, you run. Okay, so that little rant out of the way, let's multiply these. So here's how you do the distributive property. First, you take the 3x and you multiply it by both things in this set of parentheses. So we do 3x multiplied by 2x, and then we do 3x multiplied by negative 5. So just like that. You could also do plus 3x times negative 5. That would be fine.
Why didn't you put the 3x in front of the 5?
Just because it was going to be a negative, so I wanted the minus sign there. It'd be totally fine to do plus 3x times negative 5. That would be cool too. Both fine. Okay, then we're going to take the negative 2 and multiply it by both of these. Positive 2. So 2 times 2x, that'll be our first thing. So positive 2 times 2x. And then I'll do it the way you wanted to a minute ago. 2 multiplied by negative 5 would be plus 2 times negative 5. That is distributive property. Now this step that I wrote right here, eventually you're going to get where you're good enough at these that you don't have to write this step. We're going to practice that here in just a little bit, not writing that step. But I want to do it at least one time so you can see where this next bit comes from. Now we're going to multiply like we've been doing. What is 3x times 2x?
6x.
Would you like to use a lifeline? 6x squared, thank you.
Square.
Okay, then what?
15. Negative 15.
Right, so minus 15x. Plus 4x.
Well, actually, no. That'd be negative.
Minus 10 plus negative 10 isn't the worst thing ever, but minus 10 is better.
Yeah.
Okay, cool. Can we combine any of these things?
4 and the 15.
Yes, we can. These two right here can be combined. Good. So that would give us 6x squared minus 11x minus 10. Distributive property. That's all this is, distributive property. Don't get freaked out. They're going to get bigger. We're going to get bigger problems. Don't get freaked out. It's distributive property. Okay? Let me show you a tricky one that everybody misses. You're going to miss this one time, and I'm going to forgive you. If you miss it 2 times, we're not friends anymore. One time in your life, you are going to make the mistake, and you're going to say, oh, that's 2x squared and y squared. You're allowed to do that one time, and I'm going to count it wrong, but we'll still be friends. If you miss it twice, my Twitter is going to be nothing but subtweets about what a miserable person you are. Because what does squared mean? Times itself. So this is equal to 2x minus y times 2x minus y. And now it's distributive property. Squared means times itself. You're going to mess it up one time, and that's okay. Don't mess it up twice or you're dead to me. All right, let's see if you can do this. Let's see if we can skip this step where we wrote down what the multiplication was going to be and go to this step, what it looks like after we multiply. So let's do 2x multiplied by 2x. That gives us, there we go. Good. And then we do 2x times negative y. How about negative 2xy? Okay? Then we're going to distribute this negative y. Negative y times 2x is?
Negative 2x.
Good. And then negative y times negative y.
It's a positive y, isn't it?
No. Positive.
1.
Positive y squared. Y times y is y squared. Okay. Do we have anything in this problem that can be combined?
Yes.
Yes. What are they?
The 2 in the middle.
Yep. The 2xy's. So we'll have as our final answer 4x squared minus 4xy plus y squared. Okay, so that's a binomial multiplied by a binomial. I wonder what's coming next.
Trinomial?
How about a binomial multiplied by a trinomial? T plus 2 multiplied by 3t squared minus 4t plus 2. All right? First we distribute the t 3 times. Times this, this, and this. This is why FOIL's dumb. FOIL doesn't work for this kind of problem. So t multiplied by 3t squared is?
T. Oh, wouldn't that be 3t
Cubed.
cubed?
Good. T multiplied by negative 4t.
Means it's negative 4 squared.
Negative 4t squared. Good. And then t multiplied by 2.
Makes it positive 2t.
2t. Or not 2t.
Make sure
Okay, now what?
distribute the 2.
Exactly. 2 multiplied by 3t squared.
6t squared.
Squared. 2 multiplied by negative 4t.
Is, oh, 8, negative 8, t.
Good. And finally, 2 multiplied by 2.
Is 4, positive, plus 4.
Okay, good.
Yes, you have.
We have some stuff that can combine. Let's start with the biggest exponent, which is t cubed. We don't have any other t cubes, so just 3t cubed. Then let's look at t squared. We got a negative 4t squared and a positive 6t squared.
Makes it a negative 2t. What is it? No, positive.
Positive 2t squared.
And that's t.
Then the t's. We got a positive 2 and a negative 8.
So that'll be a negative 16 plus 4.
And there we go. Okay, so we did monomial times monomial, binomial times monomial, binomial times binomial, binomial times trinomial.
So if you see like that one of the
What else could we do to make this harder? Hey, I have an idea. That is a good idea.
and that's what I was just talking about.
Now you might have thought trinomial times trinomial was next. No,
Should be
that's
something.
coming though.
So you just do that 3 times.
It's that 3 times. So what this looks like is 3a plus b times 3a plus b times 3a plus b. So rather than try to figure out like how do I distribute between 3 things, we're going to use a different strategy here. First, we are going to multiply these 2 together and get an answer. Then we're going to multiply the answer by 3a plus b. So let's just do this. Okay. So 3a times 3a, 9a squared, good. 3a multiplied by b,
B squared.
3ab.
Oh,
Then b times 3a, 3ab again. And then b times b, b squared. Anything that can combine?
I have 3 B's.
Yep. So our final answer is 9a squared plus 6ab plus b squared. Now that we have that done, we're going to take this piece and multiply that. Like so. So here's distributive property again. So 9a squared multiplied by 3a gives us
27 to the third.
And then 9a squared times b. Yep, 9a squared b.
9AB.
Okay, then 6ab times 3a. Good. And then 6ab multiplied by b is Finally, b squared times 3a.
Is 3ab.
Good. And then b squared times b,
Is b squared.
b cubed.
Oh,
Now that's a pretty hefty problem. But I'll bet you can do it. Probably. I don't know. Let's start with the biggest exponent, which is a cubed. Any other a cubes? Nope. Next would be a squared. We got two things with a squared b in them, right? For a total of 27 a squared b. Then we got two things with ab squared for a total of 9 ab squared. And on the end, b cubed. So you can start to see, especially in this problem, that in some cases the multiplication gets a little unwieldy. Right here we were doing a trinomial multiplied by a binomial, and it was starting to get messy by the time we got to the third one. So it turns out there is another method that you can do to solve these types of problems that keeps things a little more organized, and it's called the vertical method. And the vertical method looks like this. It looks a lot like old school multiplication. If I did 341 times 12, we would set it up just like this. And we actually follow a lot of the same rules as we do with the old school multiplication. For example, we start off the exact same way, which is that we take the 2 here and we multiply by the 1, the negative 4y, and the 3y squared. Okay? So 2 times 1 is 2. 2 times negative 4y is negative 8y. That was a positive 2, so let's put a plus there. And then 2 times 3y squared is 6y squared. Now in old school multiplication, when you get ready to multiply the second thing, it depends on how you were taught. I was taught put a 0 right here. You might have been taught just leave this blank and start writing stuff here. It doesn't matter which one you do. I was taught 0, so that's what you're going to get taught. Put a plus 0 there. And then we take the y and we multiply it by all three of these things. So y times 1 is y. Y times negative 4y is negative 4y squared. And y times 3y squared is 3y cubed. I want you to notice something really important here, which is the way everything lines up. This first column has all of our plain old numbers. This column has all the y's, then the y squareds, then the y cubes. You have to make sure they're lined up like that because our last step is to add straight down, just like you do in regular multiplication problems. 2 plus 0 is positive 2. Negative 8y plus y is negative 7y. 6y squared minus 4y squared is a positive 2y squared. And then we just bring down the 3y cubed, and that's the answer. What's that? It's got pros and cons to it. It's got pros and cons. But in general, yeah, I really like this method. and it sets you up well for division, which is what we're about to do. The important part of division is also the important part of this method, which is keeping everything lined up, keeping the numbers on top of each other and the y's and the y-squareds. That is an important thing to do. Okay, let's do another one of these vertical, and I'll show you what it looks like when they don't line up quite as nicely. Let's do 2x cubed minus 3x plus 4 multiplied by x squared plus 1. Now I have to make sure when I multiply this that I leave a spot for every one of the exponents, meaning there needs to be a spot in here for x, x squared, x cubed, x to the fourth, so that I'm able to line everything up. That is important for reasons that will become apparent right now. Let's do 1 times 4, which is 4. 1 times 3x is negative 3x. And here's where it gets weird. 1 times 2x cubed is 2x cubed, but I'm going to leave a blank spot here for x squared. Since I have an x and an x cubed, but no x squared, I'm going to leave an empty spot and put the 2x cubed here. I'm leaving that column open for x squareds.
Okay.
Then, you put down your plus 0. First thing we do here is x squared times 4, which is 4x squared. That goes in the x squared column that I left blank on the top row. Then x squared times negative 3x is negative 3x cubed. And then finally, x squared times 2x cubed is 2x to the fifth. And then I add them straight down. 4 plus 0, negative 3x, positive 4x squared, negative x cubed, technically a 0, 4x to the fourth here, and then 2x to the fifth. So this is why I said that it has advantages and disadvantages. When you have gaps in it like that, it becomes pretty confusing. It's pretty confusing when it's got those gaps. I actually do want to show you a third method for how you can multiply these. I showed you distributive property, and I showed you the vertical method. This is not really an official math method, I just really like it. The box method. If you're having trouble staying organized or you're worried you're going to forget something, the box method is a really, really good way to make sure you get everything covered. And we're going to do this with an extreme problem. We're going to do a trinomial multiplied by a trinomial. You could do this with distributive property. It would get pretty confusing because you're multiplying so many things together. You could do this with the vertical method. It would get pretty big because it's a 3 by 3. So I'm going to show you the box method. The box method is just a really fancy way of doing distributive property. We're multiplying a trinomial by a trinomial, so I'm going to create a box here that is a 3 by 3 grid. I'm going to do 3 rows and 3 columns. Just like that, 3 by 3. It's like playing against a militant tic-tac-toe expert. So across the top of this box, I'm going to write my first trinomial. It was 2x squared minus 3x plus 4. And along the side of the box, I'm going to write the other trinomial, which was x squared plus 5x minus 2. You may remember doing something similar to this in your science classes. This is just like a Punnett square, if you remember those. It's the type of square you use to find genetics, recessive and what's the other one? Dominant genes. the Punnett square. It's also what you do on fourth down. So the way that you fill in each one of these squares is the same as you do on a Punnett square, which is that you multiply the two boxes together. So for example, this is x squared and 2x squared, and the intersection of those boxes would be 2x to the fourth. X squared times 2x squared is 2x to the fourth. Okay, let's fill in this box. This box would be the multiplication of 5x and 2x squared, which is 10x cubed. And then this box is the intersection of -2 and 2x squared, which is -4x squared. So our first column is filled in. We just did like kind of sneaky distributive property. We did 2x squared multiplied by all three of these, which is what we would have done using the distributive property. 2x squared times this, this, and this. We did it, we just organized it this way. Now we're going to do 3x multiplied by all three of these. So -3x times x squared is -3x cubed. -3x times 5x is -15x squared. And then last, -3x times -2 is a positive 6x. So now we've distributed the -3 to all of them. Last, we're going to distribute the 4 to all of them. So this will be 4x squared. 4 times 5x is 20x. And then 4 times -2 is -8. Now all that's left for us to do is to combine our like terms. Let's start with the biggest exponent and work our way down. Biggest is 2x to the fourth. Nothing to combine with that guy. Next biggest is x cubed. We do have some x cubes. A -3 and a +10. So that's a +7 x cubed. Then come the squareds. 4x squared and -4x squared cancel. So I'm just left with -15x squared. Next come my x's, 20x and 6x, 26x. And then poor -8, doesn't have any friends. And there it is. Yes, math is amazing. I am also impressed by me. Does anybody have any questions about any of these types of multiplication?